We're on number 9 in this list of integrals from Princeton University. Integral from -1 to 2 dx over 4 plus 2x plus x squared to the 5/2 power. Okay, so how do we approach this guy? Again, there's probably multiple ways to do it. I personally, if it's even possible here, I don't even know. I personally don't like to substitute anything related to those hyperbolic trig functions and inverse hyperbolic trig functions. I avoid them at all costs. I just don't like them. And you don't really need them, actually. Okay, so how do we approach this guy? Well, can we factor the bottom? It's not factorable, is the issue. So it might be a good idea to complete the square then, so that we can get a something squared plus or minus something squared and maybe do a trig sub. Hopefully you learn about completing the square in that section, or even completing the square, we might be able to do some partial fraction decomposition maybe. All right, so that's what I tried first, completing the square. So how do we complete the square? To review, this term in front of the second degree term has to be a 1, which it is. We take the term coefficient, I should say, in front of the first degree term, so 2. We divide it by 2, which is 1. We square it, so the 1 squared is just 1. Okay? We have to make it the same, though, as up here. So 1 plus 3 equals 4. So this 4 I broke up into a 3 plus 1, basically. Okay? So then I can rewrite that as 3 plus x plus 1 squared, like that. And then that's all to the 5/2 power on the bottom. Okay? Now I made a substitution. T is x plus 1, dt is dx then. This is a definite integral, so we got to change our limits. Don't forget that. Okay? So integral from 0 to 3 of dt over 3 plus t squared to the 5/2 power. So now something squared plus something squared, technically that's root 3 squared, right? I can do a trig sub. If you're not familiar with how to set up a triangle, I would recommend watching my crash course in trig sub video. Not going to go over the details here, but this would be the triangle that you would get once you set it up, okay? Now we need to substitute everything in this integrand in terms of theta. So how do we get t? Well, t over square root 3 is tangent theta, right? So square root 3 tangent theta is t. dt is square root 3 secant squared theta d theta as a result, okay? We could also substitute this term over here, okay? So square root of 3 plus t squared, that is square root of 3 secant theta. Now I just fifth power both sides. I believe this is very similar to the first problem, if I remember correctly. So then 3 plus t squared to the 5/2 power is square root of 3 to the 5th power times secant to the 5th. Okay? Again, since we made another substitution, we got to change our limits of integration. Okay, so you got to be good with the trig here. So once you switch the limits, it becomes 0 to pi over 3. Okay? Now we substitute everything. You should get this. Now we start simplifying. So we would have square root of 3 to the 4th power on the bottom. So that's just 3 times 3, which is 9. So 9 out in front. Okay? Or I guess I did that in 2 steps. Okay? And then secant squared divided by secant to the 5th. That's secant cubed on the bottom. And this becomes cosine cubed. And this is exactly like the very first problem, if I remember correctly. Cosine cubed, how do we find that? This is a typical trig integral. Save one factor of cosine. And that cosine squared we change as 1 minus sine squared. Okay? Now, just make another substitution. I'm going over quickly now because you can see the exact same thing on problem number 1 if you need to. Okay, and then notice we make another substitution. We got to change our limits once more. Okay? Now, from here, it's just power rule and then fundamental theorem of calculus. Okay? So the point I want to make here was see how useful it is to change the limits when making a substitution. Otherwise, 3 back substitutions we need it. So imagine going from u, we have to, oh, what's the definition of u? Sine theta. So we back substitute sine theta. What's the definition of sine theta? We got to look at our triangle. Sine theta is t over square root of 3 plus t squared. Okay, and then what's t? T is x plus 1. And then we have to evaluate all that algebra with all the square roots and all that now. So, because the sine theta, remember, just now was t over square root of 3 plus t squared. So we have to do algebra with square roots. Notice how nice the algebra was when we changed the limits. There's only one square root over here. Okay? So, to get the point across, hopefully change in limits instead of back substituting. It's usually much nicer. Okay. All right. Hopefully this was helpful if you got stuck on this particular integral or if you were interested. Thanks for stopping by. And hopefully see you in the next video as well. Bye.